Hello, this is chapter 7.6, natural logs. Connection between natural basis exponential functions and natural logarithmic functions. Okay, we're using the little E button now in your calculator. So we need to sketch and label a graph of e to the x. Well, if I just put a couple answers down, for instance, e to the 0, we know that's going to be 1. If we, on your calculator, if we put e squared, and actually that is 1. My apologies. So if that's e to the first, if we do e to the third, we get 20. If you do e squared, you actually get 7.39. So if we graph these, we know at 0, 1, we're going to have that y-intercept, and then we get this function that comes through here and goes up. So this is y equals e to the x. If we graph the ln, so in other words, the natural log, we're going to get what looks like the inverse log, where it goes through 1, 0, comes up, and goes over here. So this is the ln of x. So if we need to find the inverse of y equals e to the x, and then sketch on the same axes, well, let me show you how we got that. Remember, inverse, we're going to switch the x and y, so we get x equals e to the y. Okay, the rule, when we see e, we're going to ln, meaning natural log. So we're going to go natural log x equals natural log e to the y. The properties still apply, so if you notice on the right, we have an exponent y. We're going to bring out this y in front of the ln, and now we're going to get ln of x equals y times the ln of e. In properties, if you were to hit your calculator and go ln of e, you actually get 1. So, little side note over here, we get log base e, which is really equal to ln of e, which are both equivalent to 1. So over here, we actually have now y times 1 is equal to ln of x, or y is equal to the ln of x. So this graph over here, when we go ln of 1, ln of 2, ln of 3, ln of 4, gives us this logarithmic function right here on the left. Okay. Definition of a natural logarithm always has a base e, so the ln v equals u is really e base to the u equals v. So we're going to use our calculator. If you take your calculator, plug in these values and see what you get, and then we're going to rewrite the natural logarithm expression. E squared, you should get 7.389. Okay, if you hit e to the negative 1.5, you should get 0.223. If we rewrite these as natural logs, okay, you should get ln. So remember, the answer is equal to the exponent, so it equals 2. So we go, okay, this is the ln of 7.389 equals 2. Remember down here, this little base e. Okay. So then this one should be the ln of 0.223 equals negative 1.5. If we go backwards and you use the ln button, ln of 0.789 should be equal to negative 0.237. And the ln of 14.2 should be equal to 2.658. If we go backwards and rewrite these now as e bases, we're going to say it's e to the equal to. So we have e to the negative 2.37 equals 0.789, and e to the 2.658 equals 14.2. So know how to both go from Euler's number e to ln and ln to e. And now we're going to use these properties of inverses to evaluate without our calculator. Okay? Without the calculator, if we notice, it is in e form. So we're going to take this answer, it goes in front. So 3.78 times ln of e. If you remember, ln of e is equal to 1, so the answer is just 3.78. Okay, number 2, if you notice, e to the ln base e is this. Well, if we remember, this ends up being 1, or the answer is just square root of x plus 3, just like the last properties. Okay. More examples. We're going to write each expression as a single logarithm. We're going to do a couple with you and then let you do the other two. So number 1, properties still apply if we have a negative or a minus. Notice we're going to use division. So this is ln of 16 over 8, which is equivalent to ln of 2. Okay. Number 3, remember if there's a number in front, we can apply that to the exponent on the a. So we have ln of a to the 1/2 minus ln of 2 to the b. The minus represents division. Ln of a to the 1/2 divided by 2b. Go ahead and hit pause. Do number 2 and 4. Welcome back. If you notice, we get 5 times the ln of 3 and ln of 2 for 4. What I first did over on number 2, took the 3, brought the 3 over to the exponent here, changed the 9 to 3 squared. The plus signifies multiplication, so we really have 3 cubed times 3 squared, which is 3 to the 5th. Okay, and over here, did the kind of the same thing. Change the 4 to 2 squared, and then raise that to the 2nd power. Change the 8 to 2 cubed, and end up having to divide. We have 4 2's on top, 3 2's on bottom, so we're left with the 1 2. More solving. We're going to jump over to number 3 real quick. So number 3, you have the ln of e. Based on this, we know the exponent rule says we can bring it out in front. So we have x plus 5 times the ln of e equals 17. Okay. Now we need to know and remember that ln of e is always equal to 1. So on the left-hand side, where you have x plus 5 is equal to 17. When we subtract 5, you get x equals 12. Go ahead and hit pause. Try number 1 and 2. See you back here in a few minutes. Welcome back. You should have gotten x is approximately 1.58 and x is approximately 1.85. I know some of you would think to move this 5 to this exponent here, but now you have 4x minus 6 to the 5th power. That's fine. Probably easier just to divide by 5, which is what I did. Remember, you have 1 log, or in this case, 1 natural log. Rewrite it exponential. So I went from here to here. Okay. Add the 6 over, divide by 4, 1.58. Okay. On the second one, this plus signifies multiplication. So we have 4x. Again, you see 1 ln, so I rewrote it as an exponential. E to the 2nd equals 4x. Divide by 4, plug it in your calculator, and we are good. Alright, using natural logarithm to solve each equation. Round your answers again to the nearest hundredth. Kind of the rule, if you see e, we're going to natural log. If you see ln, we raise that from the e power, or e to that power. Okay, so for instance, we're going to do number 3. Okay, first thing, we need to get this x by itself. So if we subtract 6, we have negative e to the 12x equals negative 0.8. We're going to divide by the negative 1, and we get e to the 12x equals 0.8. Okay. You have an e, or Euler's number, raised to the power of 12x. We're going to put an ln. So we're going to put an ln in front, which means we're going to put an ln in front. So ln of e, 12x, equals ln of 0.8. This now, exponent 12 times x, can come out in front. And we have 12 times x times the ln of e equals the ln of 0.8. The ln of e is 1, so we have 12 times x equals ln of 0.8. Divide by 12, and x is approximately negative 0.019. Remember here, right here at the top, okay, you can't take negative logs. Hopefully we can divide by that negative 1. Go ahead, hit pause. We'll see you back here in a few minutes. Okay, welcome back. If you notice, we try and get the e to the x power over on number 1 by itself. Then when we see e, we put an ln in front. So ln of e to the x equals ln of 5/2. ln of e, remember, is 1. So we end up getting 0.916. On 2, you end up getting 17.33. And on number 4, one quick step, make sure you subtract the 5. If you notice, when we have e to the x plus 6 equals -4, when you take the natural log of -4, you get something that's undefined and cannot do. So right there, stop. You cannot have that. We get no solution. Moving on. Go ahead, hit pause. Just a quick review. Solve without using your calculator, please. Check back with me in a few minutes. Alright, welcome back. Please check with me if you have any problems. A should be equal to 32, and x should be equal to -13/2. 3. We're going to solve graphically with our calculator, round to 2 small places, and then we're going to solve the next one by using natural logs. By graphing, if we have 3 to the x equals 4, really we're just going to set one side equal to y, 1, and the other side is equal to 4. So here's 3x, here's 4. If we graph this, we get a line that's 4. So here's our 1y equals 4, and we're going to get another exponential that's going to raise or triple. So this is going to triple. What we're interested in is those two are equal at this value, at this x. So we're going to find that and that point. If we hit calculate, special way, you'll see that that x value is 1.26 and the y value is 4. We're interested in the x, so x is approximately 1.26. Okay. The other way of doing it, natural log way, kind of the same problem. If we have 5.3 raised to the x equals 64, we're going to put an ln in front. So we have ln 5.3x ln of 64. This x is going to shoot out here. So x times ln of 5.3 equals the ln of 64. If you remember, we're going to divide by ln of 5.3, and your x is going to be approximately 2.49. Congratulations. Do your best, forget the rest. Bye for now. Or